Good morning, everyone. Carahsoft would like to welcome you to our Acalvio webinar. Carahsoft Technology is a trusted government IT solutions provider delivering software and support solutions to federal, state, and local agencies. Carahsoft maintains dedicated teams to support sales and marketing for all of its vendors, including Acalvio, Splunk, AWS, Forescout, VMware, and Okta. We are offering 1 CPE credit to those who attend today's webinar. In order to qualify for the credit, you must be actively listening as well as answering any polling questions that will be presented. If you meet all of the requirements, you will receive your certificate within 2 weeks. At this time, I would like to introduce our speakers for today. Kevin Fiskus, author of SANS SEC 550, Cyber Deception, Attack Detection, Disruption, and Active Defense, and Imran Umar, Senior Cyber Solution Architect at Booz Allen Hamilton. Imran, the floor is all yours.
Great, thank you. Let me quickly just bring up the slides. Okay, we're all set. All right, well, welcome everyone. Good afternoon. I'm Imran Umar. I'm a Cyber Solution Architect here with Booz Allen Hamilton. I spearhead our Zero Trust practice. So we have an exciting agenda today. We will start with providing a quick introduction on Zero Trust. We'll talk about what Zero Trust is. We'll go over high-level architectures in terms of how do you adopt the Zero Trust technology and capabilities. And we will then get into deception strategy and why it's so critical in accelerating threat detection and response. Let me also start with providing a quick overview of Booz Allen Hamilton. So Booz Allen, for those that are not aware, is one of the nation's largest cybersecurity provider across the DoD, federal, civilian, and the intel community. We have a fairly large Zero Trust practice where we do everything from a Zero Trust maturity assessment, which is, we'll talk about this in the next few slides. We build architecture and roadmaps, and we actually do the actual implementation work to help customers move towards this new security paradigm. We're currently implementing Zero Trust across the .gov, including the Department of Defense. One of our marquee projects right now is called Thunderdome, that started off as a pilot and now moving to an enterprise deployment. Thunderdome is a DoD Zero Trust architecture where we are providing conditional access for remote users and devices accessing resources through both remote and on-premise. Okay, let me just move to the next slide. All right, so let's talk about what Zero Trust is. And I'm guessing a lot of folks have heard the word Zero Trust and they're aware of the word Zero Trust, but I'll kind of set the stage by just providing a quick overview, right? So Zero Trust, at the end of the day, is a new security paradigm that eliminates implicit trust and moves away from traditional perimeter-based security models in which everything inside your enterprise was considered trusted. So once you're past the perimeter, the users or the devices, they had easy access to the enterprise data and systems with limited policy enforcement and access validation. Well, why is adopting Zero Trust becoming so important? Well, the technology landscape is evolving. As organizations rapidly pursue things like digital modernization with increased adoption of cloud, there's more adoption of mobile devices, bring your own devices, for example. Folks are embracing remote and hybrid work. All of this has led to a change in the attack surface, which cannot be protected using traditional static security perimeters. As such, our approach to security must change. Furthermore, our adversaries are increasingly become more sophisticated. Not a day goes by that you don't hear about a ransomware attack, a modern phishing attack. So we need to shift in how we protect our critical data and systems. And this is why organizations are embracing Zero Trust. So what do you typically hear about Zero Trust? So never trust and always verify. So all requests, access to data, applications, assets, and services are denied by default. Least privileged access. Access to application data and services should be restricted to the right needed to perform an approved role. So if you don't have a need to access a certain application or a certain system, you will be denied and you will be provided least privileged access if you are intended to access that resource. This assume breach mentality, which is kind of one of my favorite, right? Because you have to have this mindset that the adversaries, I mean, think of SolarWinds, right? They're already inside your network. The threat actors are inside your network, and how do you protect your environment? By doing things like segmentation, reducing the blast radius, providing continuous visibility, and remediation. What you sometimes hear about zero trust. So zero trust is a mindset change. So you cannot just go and buy a tool and deploy it in your environment and say, I am zero trust ready. It's a mindset change. Zero trust is an ongoing journey that includes people, processes, technologies that all have to come together to start implementing this new security paradigm. And it's cross-cutting, and I'll talk about what I mean by cross-cutting in the next slide. So we think of zero trust across these different pillars, and you will see different variations of these pillars. Some are 5, some are 7, but at the end of the day, they all are trying to, they all try to mean the same thing. Both CISA, NIST, DoD, and NSA have put out zero trust reference architectures, and they talk about these pillars in their specific architectures. So the very first one is the user pillar, right? So this is very important. How are we authenticating and authorizing a user using the least privilege principle that I just talked about? Devices, understanding that the device that's connecting to the network, is it compliant? Does it meet all of the security requirements before it's able to get access to your environment? Let's talk about network and environment. So segmentation is a very important thing, right? So traditionally, we have only focused on north-south traffic inspection, but more and more, we have seen adversaries access our environment through lateral movement. How do you stop lateral movement? Well, you do that by implementing things like microsegmentation, where you prevent east-west, traffic movements. Application workload. This is very important because applications, you have applications sitting in your traditional on-premise data centers. There's been a lot of application workload migration to the cloud. Well, how do you ensure protection? How do you ensure segmentation? How do you ensure access control? So implementing zero trust principles to protect those application workloads, whether you're a hybrid architecture or multi-cloud architecture, is very important. The data pillar. Now, this is the most challenging one. So this is where you essentially come in and identify all of the critical data that you have within your environment. You must classify that data. You must tag that data and use things like attribute-based access control to implement conditional access. Visibility and analytics. This is a lot where deception also plays a key role that Kevin will get into. The main thing here is how are we collecting all of the logs? How are we taking all of the telemetry and using smart technology, including things like artificial intelligence, to be able to process those logs and identify the threats? And then finally, how are we automating and orchestrating not just the response time to remediate threats, but how are we automating the deployment of our infrastructure, automating the implementation of our application workloads, our network segmentation, et cetera. And all this is underscored by what is around governance, right? So you need to have a strong governance policy to be able to implement, policies that the firm has agreed to and policies that would then be implemented to, adopt things like conditional access. One more important thing on this slide I'll touch on. You have to, from a zero trust perspective, you have to take a look at integration of all these capabilities together. So it's not only the authentication of the user, not only verifying the user, the device health posture, but it's a combination of all those factors that you need to take into account before giving access to a resource. So the integration and the fusion of all these different technology components across the pillar is very critical. Let's talk about a maturity assessment. So when the executive order came out around 2021 that talked about, hey, the federal government shall move towards the zero trust paradigm, a lot of organizations across the civil organization and the Department of Defense were like, well, where do I start? Well, we have this really nice zero trust architecture put out by CISA and DoD, but how do I understand my current baseline, and how do I move towards the zero trust architecture? So what Booz Allen did was build a zero trust maturity assessment capability. So if you look at the very top, the very first thing we do is we do a current state assessment. So what is your objective? What are the current strengths and weaknesses of that organization? Then we take a look at the existing tools and technologies. Obviously, you have invested in existing capabilities, whether it's a SIM product, whether it's your endpoint security product, whether it's your ICAM solution. Where are you from a tools and technology perspective? Where are there overlaps? How are these tools integrated? And then stakeholder target definition. What are the stakeholders trying to do? What is the outcome? What is the roadmap that the CIOs are trying to achieve? We then take that and start moving into the next phase, which is the actual implementation of a zero trust, actually development of a zero trust roadmap. The very first thing we recommend is select your maturity model of choice. So if you're a federal civilian agency, you want to adopt something that CISA or NIST put out. If you're in the Department of Defense, you want to take the DoD and NSA zero trust maturity model, and then start defining the targeted states. You want to take a look at across all of those different pillars and identify relevancy, identify maturity. So where are you from a user perspective? Are you implementing mature capabilities? From a visibility and analytics perspective, are you collecting the logs manually and processing them? Are you implementing advanced technologies like deception to do threat detection? And then finally, from there, it's the step 4, which is the recommendation. So we not only do the current baselining of where you are today, we help build roadmaps from a zero trust perspective, and then we help with implementation. And we've successfully done this for a lot of organizations across the federal civilian and the Department of Defense. There is no one approach to adopting zero trust. Each organization is different. Each organization, their people, their process, the technologies are different, right? So this particular architecture model just gives you a high-level overview of what a baseline zero trust model would look like. So if you look at the very top, you have local endpoint, you have remote endpoint, and remote mobile endpoint. They're coming in and accessing a variety of different resources. Resources could be everything from O365, ServiceNow sitting in as, being provided as a SaaS service. It could be your on-premise infrastructure, on-premise HR legacy systems, for example. It also could be IS and PaaS services sitting in one of the cloud service providers. So as the users are coming in remotely, we are validating the device compliance. So we're looking at the device health posture. At the same time, we're also taking a look at the user identity and behavioral analytics. For example, if Imran joining in from a different country, like in Singapore, 2 a.m. in the morning, is that normal behavior? So taking into account environmental factors, device health posture, and user identity, and these are just examples of some of the attributes we would consider as we would apply what's called conditional access. So we are basically looking at the device posture, user identity, behavioral analytics, and determining using this policy engine is, does this user meet all of the basic requirements based on the governance and policies? And do they have access to the resources that, do they have the permissions and the need to access the resources that they're trying to access? The other big thing is obviously, at the bottom left you see here is we are tagging all the data, encrypting all that data, and classifying the data. So if I'm sending that data to someone that shouldn't be receiving that data, it will get flagged and rejected. On the right-hand side on the top, you also have third-party external partners, right? Vendors and others that are coming into your environment. We will basically implement a very similar conditional access policy for them as well. And then all this data is then fed into your logging and alerting capability, where incident response and SOC analysts would take remediation actions. So this is a general architecture. Like I said, there's variations of this depending on the organizations. They could start at the user pillar, they could start at the device pillar, they could start at the data pillar, but it all depends on organizational maturity, the roadmap, and their overall current status. All right, with that said, I'm happy to now pass it along to Kevin, who will kind of go over the deception technologies.
Awesome. Thank you, Imran. I'm going to go ahead. Okay. Excellent. Thank you for releasing the screen. Appreciate that. So yeah, thank you so much for that. That was a great overview of zero trust. Let me just make sure. Okay, yes. Okay. So yeah, that was a great overview of zero trust. I kind of look at zero trust. Well, actually, before we jump into that, so again, my name is Kevin Fiskus. I'm a principal instructor with the SANS Institute. I also run a couple of consulting companies. I've got a YouTube channel focused on cyber deception if anybody is particularly interested in all of that kind of stuff. But that's not what you guys are here for. What you guys are here for is to learn some things about zero trust and the concepts of cyber deception. When I think of zero trust, there are two key events that sort of stand out in my mind, at least in my memories. One of those happened back in, I want to say it was I forget the exact date. It was 1980, late 80s, early 90s. May have even been late 90s. I don't remember exactly, but in the early kind of that time period, you may be familiar with a gentleman by the name of Kevin Mitnick. Now, Kevin Mitnick is a noted hacker. He currently operates as a security consultant, but way back in the day, Kevin was a hacker, right? He was an old school, I break into computers hacker. And one of the things that he's most widely known for is his interactions with another guy by the name of Tsutomu Shimomura. And so just to go over this super briefly, Kevin Mitnick wanted to get access to a computer system that Shimomura had access to. And Shimomura back in the day would log in using the R protocols, like R shell and R login. And the thing about those protocols is that they predominantly utilized nothing more than a source IP address for authentication. And what Kevin Mitnick was able to do was execute a denial of service attack against Shimomura's computer. He then identified a weakness in the sequence numbering, the development of sequence numbers in the IP protocol, and he was able to spoof Shimomura's IP address in order to execute an R shell command, which ultimately gave Kevin Mitnick access on an ongoing basis. And I think of that whenever I think of zero trust, because that is the opposite of zero trust. That's like the I'm going to trust based on nothing more than superficial resemblances. So that to me is the almost the trust everybody type of a deal. And I think of that as kind of the unofficial, and it's only in my head, story of where this journey to zero trust began. And then another example that I had, and this one happened, I want to say in the it would have been in the mid 2000s. So think about 2006, 2007. I was doing work as a security consultant, and I had a client. Now, again, think back 2006, 2007 timeframe. I had a client, but the way that they architected their network is they took everything off of their sort of production local area network. They put all of their mission critical resources, all of their key applications and databases and all that kind of stuff into a centralized data center. Yeah, they had some print servers and stuff like that and domain controllers on their local network, but predominantly everything of value was put in their data center. And this was kind of in the days before cloud was a big thing. And the way that they had their architecture structured is it didn't matter where you were. It didn't matter if you were on their local area network or if you were coming from the internet. They only allowed access via, I forget if it was like remote desktop or Citrix or something like that. And I thought that was a really cool model. I'm like, this is awesome. It doesn't matter where you are. It matters who you are. And that kind of is another piece that always comes to mind when it comes to zero trust, is this aspect of it doesn't really matter in this day and age where you are physically located. The fact that you may be connected up to my network doesn't give you permissions on my network. And I love the model. I think that zero trust is absolutely fantastic. The challenge, and as Imran kind of alluded to, zero trust isn't like going and buying a firewall, right? It is a strategy. It's not a piece of technology. And it requires a very different mindset. It requires potentially the integration of a lot of different technologies in order to work properly. So there are definitely some challenges to that. Obviously the integration of all these different technologies, the legacy technologies that you already have in your environment, those things may or may not support integration with a zero trust model. So you've got some of those types of things. In most cases, when I hear people talk about zero trust today, there is a huge focus on cloud, but you do have sort of different models, as Imran had stated, whether we're talking about cloud, on-prem, hybrid. There are a couple of different sort of design models that are out there. The other piece of it that Imran said is that never trust, always verify. And that sounds great. And we're going to get into this in a second. But the fact of the matter is, it's not actually possible. And again, I'm being overly technical, and I'll explain what I mean in just a moment. And then obviously, technology ends up, we end up running into vulnerabilities because technology is coded by human beings, right? And human beings make mistakes. And it's not just that a mistake can happen within one specific technology, but the integration of multiple technologies. So there's always the possibility of a vulnerability. Whether that vulnerability is a technical problem, maybe there's a zero trust policy enforcement point that has an exploitable vulnerability that it can be bypassed, or maybe it's the whole aspect of credentials, right? If I'm a bad guy, can I compromise your credentials? We'll get into an example of that in just a moment. So let's talk a little bit about this never trust, always verify. And the reason why I'm focusing on this is because it highlights where some of the challenges associated with zero trust come in. So the theoretical model is, like never trust, always verify. So my cheesy diagram here, the dotted line is showing the hypothetical. It's showing the theoretical. So on the left side, we see the always trust, never verify. And then on the right side, you end up with the opposite of that, right? The never trust, always verify. And so I have these things as the dotted lines are the hypothetical possibility. But the fact of the matter is there's really not been any significant time, at least in the last 4 decades or more, where we've ever had an always trust, never verify. So there's, at least in the last, let's say 4 decades, there's always been all right, we're going to do at least some level of verification, even if that's just simply IP address, right? And then as we've moved along over time, we get to this point of zero trust. But the problem with zero trust is if you say never trust, always verify, in theory, that would mean that you would need to independently validate every single packet exchanged between different hosts. And that's obviously not practical. Right. So there is a point where we have established a level of trust. We then identify some criteria of that trusted conversation, and then we don't verify after that, right? In other words, if I establish a trusted session and I'm exchanging packets with you, I'm not re-authenticating every single packet. We've identified this session. And it is, if you look at that sort of solid line, you'll see that both the trust line and the verify line flatten out. At some point in time, we have to, we have to deal with the fact that we just cannot independently validate every single packet. So it is where those lines flatten out. And by the way, this is not drawn to any kind of weird scale or anything like that, but it's where those lines flatten out that we end up with a possibility of attacks within a zero trust environment. So a really oversimplified version of an attack might be something like a phishing or a spear phishing campaign. So the idea is I'm going to target individual users. And whether I target those individual users and they click on the wrong link or they open up the wrong attachment, which takes advantage of some client-side vulnerability, or maybe it's not a phishing or spear phishing, but more of a direct social engineering where I end up convincing somebody to give me credentials, something along those lines is a possibility. But the idea is that as an attacker, I want to compromise end user credentials. And one of the easiest ways to compromise end user credentials would be to compromise an end user's workstation or whatever they happen to be interacting with their technological environment through. So compromise the end user's laptop, use the credentials that may be stored in memory, or extract the credentials out of memory. Now, as Imran also stated, there's also sort of situational access or contextual information. But the fact of the matter is, if I compromise a legitimate valid user and there's no indication that that legitimate valid user has been compromised, I'm not logging it at any kind of, I'm not utilizing those users' credentials in any kind of weird time of day. I appear to be coming from that user's IP address, so I'm not coming from, as Imran had said, I'm not coming from like Singapore or anything weird like that. Everything appears normal and I have valid credentials. Now, one other challenge that we might have to overcome is multi-factor authentication. And if multi-factor authentication is implemented, that becomes a fairly challenging thing. But from an attacker's perspective, there are ways of circumventing multi-factor authentication. One of the simplest ways is that within a large, complex technological environment, there are often services or functions that simply do not support multi-factor authentication, but they do support username and password-based authentication. So if I can identify a service that doesn't allow for multi-factor authentication, the credentials that I just stole from the legitimate user can now get me in. There are also ways in which, again, if I'm engaging in a social engineering relationship with a user, I may be able to get that user to provide me with the the multi-factor authentication credential, right? Whether that's the Google Authenticator code, the Microsoft Authenticator code, or whatever code, text message, whatever happens to happen. And so there are ways to kind of break myself into a zero trust environment. It's not to say that it's necessarily easy. Another way, of course, of gaining access to a zero trust environment is to identify a vulnerability in a policy enforcement point. So literally just break through the walls if we're there. And then as the attacker, once I gain some level of access, I then want to kind of go into this aspect of things like lateral movement. And I want to see what else I can do. The likelihood is if I gain access to one system, that initial system doesn't really contain the information that I want to get access to. So I want to start lateral movement, privilege escalation, those types of things. So I'm going to look around. I'm going to look at the system that I've compromised, look at things like ARP cache and DNS cache and browser history, things along those lines to try to figure out where else I can go. And then I just sort of continue that process over and over and over again. And so if this was to happen at a very high level, there are a couple of possible outcomes. One option, and sadly, this ends up being a more common option than any of us would like, is once the attacker gets in, they remain in the environment for a time period measured in weeks to months. And if we look at industry statistics, if we look at things like the FireEye Mandiant M-Trends report, their average dwell time in their last report was, I believe, 28 days. So basically 4 weeks. And if you look at the Ponemon Institute cost of a data breach study, their average dwell time, I want to say, is 201 days, right? So like something like 7 months or something like that, right? So we know that bad guys are just simply remaining in the environment for a prolonged period of time. And we'll talk about why that is in just a second. Now, the other option is, let's say that everything works well. Right? Let's say the attacker does manage to bypass our controls, they find a vulnerability, whatever, and they get in, but we detect them right away, right? Maybe it's an automated detect. Maybe we are utilizing an EDR platform, an XDR platform, an NDR platform, a SOAR platform, things that are allow for a level of automation. So we detect the bad guy. That detection is or the detected attack, the information about that detected attack is then ultimately sent to the zero trust policy engine, right? The policy engine is now aware that that particular user account, potentially on that particular system, is compromised. So we're now going to create a new zero trust policy that gets pushed out to all of the policy enforcement points, which now says, all right, this person may have a valid credential, they may be using a valid username, they may be on a validated system, but we now have credible information that that username, that system has been compromised. So now access is blocked. Okay. And that's an awesome, I mean, that is the holy grail of what most people would consider a detection situation to be. Rapid detection and then rapid ejection of the attacker as quickly as possible. Now, that sounds like a fantastic thing, but unfortunately, it does create a number of significant problems. If you want, the way that I always think about this is when we think about an attack, right? when an evil bad guy attacker tries to compromise my environment, their attacks don't work 100% of the time. In other words, the attacker tries something and it fails. It fails because they did it wrong, or it fails because we have controls in place which stop it from failing. Okay. And so what happens is the attacker tries something and it doesn't work. That not working equates to resistance, right? The attacker encountered resistance. That resistance equates to intelligence. And when I mean intelligence, I'm thinking more of like intelligence operations, not how smart the attacker is. What I'm saying there is when the attacker tries something, it doesn't work. They now know something about the control structure in the target environment. So via a process of trial and error, the attacker simply just tries again and again and again. And therefore, they figure out the things that will work against our protective controls and the things that will not work. And that's a pretty common strategy for an attacker, right? And one of the bigger problems that we run into is protective controls themselves tend to be both static and uniform. Now, what I mean by that is if you have, let's just say, an EDR solution, it is more likely than not that you have deployed the same EDR technology throughout your entire enterprise. If an attacker figures out a way to bypass or circumvent your EDR platform, they don't just bypass it or circumvent it, or they don't have the capability of bypassing or circumventing it on one system. They have the capability of bypassing or circumventing it everywhere in your environment. So what that means is attackers don't necessarily need to bypass individual security controls. They bypass types, categories, vendors, brands, implementations of security controls. So the idea as we get into there is that concept also applies when we talk about detection, and we'll dig into that in just a little bit. So if I was to accomplish that holy grail of I quickly identify the bad guy attacker in my environment, I detect them rapidly, and then I eject them. If we're talking zero trust, I implement a new zero trust policy, push that out to all the policy enforcement points, which means that that attacker can no longer interact. They can no longer hurt my environment. And that sounds fantastic, except in doing so, we have now provided the attacker with additional intelligence. They know I interacted with this thing. I tried to launch this type of an attack. I got caught and I got blocked. Now, the theory is that the attacker could just come back again. Now, you might be saying, well, we've now blocked the credential that the attacker had, and that is absolutely true. But there's nothing to say that when the attacker did their spear phishing attack or their phishing attack, they might have compromised 100 different credentials. We've burned one of them, right? So yes, it does make it harder, but the attacker still has the ability to simply learn from their mistakes if we're providing them with that level of intelligence. So anytime that we directly and sort of automatically block attackers based on detection, we provide the attacker with intelligence that they can then use to come back more prepared the next time. And the fact of the matter is we don't spend a lot of time talking about attack attribution, trying to figure out who the actual attacker was, because there's not a lot of value in doing that, and it takes a lot of work effort. So we just kick the attacker off so they don't do us any additional harm. And the attacker learns from that. Now, some attackers will just simply go away and try to find an easier target, which is a win. But if you're talking about a determined attacker, maybe you are dealing with nation-state sponsored threat actors, APT attacks, that kind of stuff, the attackers just come back with a modified strategy based on what they've learned. So all is lost, right? We can't do rapid detection and response, or can we? And the answer is we absolutely can, but there are actually 4 different functions that are required in order to do that effectively and not tip our hands to the attacker. The first thing is, I'll just call it high fidelity, low noise detection. If you look at the average security operations center, the average SOC receives around 11,000 alerts per day. That equates to something like a little bit less. I think it's 7.6 alerts per minute. The average alert takes about 10 minutes to process. So if we actually tried to look at every single alert going into this average SOC, it would require 228 8-hour shifts per day. Right? So we end up with a lot of noise that ends up going into our security operations center. Attackers also have ways of circumventing detection. So we end up missing a lot of attacks. So what we need is, again, this high fidelity and low noise detection solution, so that when we detect an attack, we know it is a true attack and we can take action based on it. The other problem with the lack of high fidelity, low noise detection is it makes having 24/7 monitoring much more difficult. Now, if you're a large organization and you have a 24/7 security operations center, you've already sort of addressed that, even though you're still getting a lot of alert overload, alert fatigue, a lot of noise, all that kind of stuff. You can do managed security services, but those tend to be fairly expensive. In theory, you could send your security people a text message every time an alert was generated, but now we're talking about 7.6 text messages per minute, which would drive your people insane. If we have high fidelity, low noise detection, we can also have a much easier job of 24/7 monitoring or 24/7 alerting. We can also feed those detection events into our zero trust policy much more effectively. Now, another thing that we need, in addition to the high fidelity, low noise detection, is detailed attack information. Now, detailed attack information is really more a function of the incident response process. It's super simple. It just means that as an incident responder, I need information about the breach in order to be able to respond effectively, in order to understand the scope of the breach and what I need to do to deal with it. And if that information is distributed all over my network and I have to go to 50 different computers to get access to that information, and there's a lot of noise and a lot of false positives, and it's a real big mess, that's going to make my incident response process take longer. And we know, based on industry statistics, that the longer it takes to detect and then respond, the higher the cost of that breach. So by having detailed attack information, incident responders could be more efficient, they can be more effective, and we can reduce breach costs. Those two things, high fidelity, low noise detection and detailed attack information, those things can be accomplished in a variety of ways. But there are a couple of other things that are super, super important. One of those is non-production resources. Now, when we talk about non-production resources, what in the world is that? Well, it literally is exactly what it sounds like. It is a server, it is a workstation, it is an application, it is a user account, it is a file, it is a directory. It is whatever you want it to be that has no kind of normal production value. The reason why that's important is a couple of reasons. First of all, it facilitates high fidelity, low noise detection. If you have non-production resources, the de facto state for those resources is no use and no interaction. Therefore, any use or any interaction with those non-production resources would be something you would want to pay attention to. But the other thing is that I don't always have the ability to respond immediately to an incident. I may not have the resources to do so. I may not get the alerts quickly enough, whatever. And so if I have non-production resources that appear to the attacker to be production resources and that are interesting, that are attractive to the attacker, I can distract the attacker away from my production resources and give them these more interesting targets. And that it gives me a little bit of time in many cases to be able to respond, because at least statistically, the attacker is going to spend some of their time dealing with or interacting with the non-production resources. And then the last thing that non-production resources gives me is the ability to not eject the attacker right away. If I eject the attacker immediately upon detection, the attacker learns something about my detective capabilities. If I leave the attacker on my production network, at any instant, that attacker could do catastrophic harm. But if I have non-production resources that the attacker can interact with, the attacker thinks they're interacting with production resources. They have no reason to believe otherwise. We can now allow the attacker to stay on our network for a little bit longer. You know, at a minimum, it means that we have a time delay between detection and ejection, so the attacker doesn't learn anything about our capabilities. And oh, by the way, while they're interacting with our non-production resources, we can learn about the behaviors, the threats, or so the motivations, the tools, the techniques, so we can basically collect cyber threat intelligence in the process. Now, the last thing that we need is what we'll call environment variability. The way that environment variability works, I want you to think about this. This is going to be the dumbest computer game you have ever heard. Okay, in this computer game, there are 5 hosts. You have to attack one of those hosts. Now, 4 out of those 5 hosts, your attack will fail. There's an effective control in place or whatever. One of the hosts, your attack will succeed. Okay, here's the deal though. When you attack any of the 4 hosts where you fail, you can come back again and try it, and the environment doesn't change. So all you would have to do at the very worst case scenario is come back 5 times, and on the 5th time, you will succeed. Well, that's basically how our technological environments are structured from an attacker's perspective. Now, it's not just 5 hosts, it's more complicated than that, but our environments don't dramatically change minute to minute, day to day, or even, you know, week to week in most cases. So the attacker just keeps coming back and trying and trying and trying and trying until they find the pathway that works. But what if we could introduce variability into the environment? So when the attacker comes in, they get kicked out, they come back, and the environment looks different. Now, we'll talk about how that can be accomplished, but that makes it much, much harder for the attacker to be able to learn from their previous mistakes. But the fact of the matter is you actually need all of these things in order to have a sort of, in order to do what I call detection-oriented design. If you don't have high fidelity, low noise detection, then you end up not being able to catch bad guys effectively, a lot of noise, a lot of missed attacks. If you don't have non-production resources, the only thing the attacker ever interacts with is production. So we have to kick them off. We have to provide them with intelligence. Without environment variability, the attacker just keeps coming back, learning from their mistakes. And without detailed attack information, the attacks take longer. The incident response takes longer, it's less effective, and our data breach costs are higher. Well, the cool thing is that cyber detection and I'm not speaking too fast, that cyber deception and deception technology gives us all 4 of those capabilities. So when we talk about high fidelity, low noise detection, we utilize what we call decoys and baits. These are those non-production resources. The cool thing about them is they actually are subject to 0 false positives. Now, that's a little bit of a controversial statement. Let me explain what I mean. A false positive in the form of something like an IDS signature is an alert that should not have been generated because the signature wasn't constructed carefully enough. So with deception, when we have these non-production environments, any interaction with those non-production environments is abnormal. It could be your security team doing a vulnerability scan. It's still a true positive. It's just a non-malicious alert. But even in those cases, I instantly know the IP address that did that. I can go figure it out. I can figure out whether it was malicious or not very, very, very quickly. And so the idea is that going to that assumed breach that we talked about before, once the bad guy gets into our networks, they can't tell the difference between our decoys and baits. A decoy is simply a system that you would put out there, and a bait would be a resource on a production system that generates an alert. The attacker doesn't know the difference, so any interaction with our decoys and baits generates an alert, and we are in good shape. And by the way, some of those things could be things like credentials that we have planted. Those decoys, specifically those decoys, basically become the term of yesteryear would be honeypots, although I try to steer away from that. These are basically systems in our environment that the attacker can interact with. So we can let them interact. Now, the ideal is that the systems look like production systems, but from the attacker's perspective, they interact with the computer, they compromise it, they gain access, they're interacting with data, they might be exfiltrating sensitive data. What they don't know is all of it is fake. It's all been planted. But from the attacker's perspective, they believe that they are winning. And oh, by the way, when we talk about zero trust environments, credentials are a huge thing. We can actually plant credentials on production systems that are decoy credentials that any use of those credentials generates an alert as well. Now, with these decoys, the decoys aren't just some random system. They're heavily instrumented systems. So that allows us to collect very detailed attack information so that we have high fidelity knowledge of an attack, and then a ton of information about what's going on in that attack that is rapidly accessible, which is a pretty awesome thing to lower overall breach costs. And then the environment variability. When we talk about environment variability, I can modify my decoys and baits, and we also use what are called breadcrumbs. A breadcrumb is a resource placed on a production system that is designed to lead the attacker to a decoy system. So I can modify those things anytime I want. I can modify them every couple of minutes if I felt like doing so. I can change their IP addresses. I can change their names. I can change the open ports. I can add stuff. I can remove stuff. So from the attacker's perspective, when they get in the environment, everything looks different and they've got to figure things out on their own. And where this can be awesome from a zero trust perspective is that once we get that high fidelity detection, we can push out a new zero trust policy. But that new zero trust policy doesn't block the attacker from everything. What that zero trust policy does is it blocks the attacker from production resources, but allows the attacker to continue to interact with the deceptive resources. So from the attacker's perspective, they still have access, even though it's only to deceptive resources. So we have now changed the environment from the attacker's perspective without the attacker being aware that that has happened, which is pretty awesome stuff. And that's what we can do when we start combining the aspects of zero trust and cyber deception. So zero trust provides that granular access control based on identity and then different types of situational context. Cyber deception provides that high fidelity, low noise detection, non-production resources. The attackers think they're winning the entire time, and we get detailed attack information. And so what I wanted to do now is, and again, by the way, questions are more than welcome. If you want to throw stuff in the Q&A tab, that's pretty awesome. But what I wanted to do, oopsie, hold on, let me do this. I wanted to do, and this is a really, really quick demo. And so the way that what I'm doing here, so the first thing I have is I've got a little simulation that I'm going to go ahead and play with here. And the idea of this simulation is I've got some Docker instances that are starting up that are going to play the role of my production network. Okay, so we can see that I've started that. And then in addition to that, I also have a decoy. Basically, the way that this is set up is the production networks all appear to be web servers, and the decoy is basically looks like an SSH server. So if I was to go in and do something like an Nmap scan, and I'm just going to scan the IP addresses that I know these have been assigned to. So 192.168.100.114, which is my decoy, and then 222, 223, whoops, 224, 225, and 226. Okay, so those are the 5 production hosts and the decoy, and I'm doing what's called a SYN scan or a half open scan. The reason why I'm doing that particular type of scan right now is because I don't want a fully established connection to happen. And if we look in here, we can very quickly see that like 114, this guy right there has port 22 open, and then everybody else has port 80 open. And if I wanted to, I could just go ahead and open up a browser. Don't need that guy there. And I can go to 192.168.100.222, and I can, well, hopefully, I don't know why that's okay. Well, that was weird. Let me do this with a different, I think it's because I'm on my local system. Give me a moment while I pop up another browser and go here. Okay, so again, super cheesy. All it is an Nginx that was a cache credential. It's just an Apache server. And if I was to go to 223, again, these are production systems, right? So this is just interacting with production resources like I normally would. Okay, so the next thing that I'm going to do, let me close this browser thing here. The next thing that I'm going to do is I'm going to intentionally interact with the decoy. And the way that I'm going to do that is I'm just going to do an nmap scan. But this one's going to be what's called a connect scan. And I'm going to connect up to port 22 on 192.168.100.114. So all I'm doing here is simulating any kind of detection, right? This happens to be a deceptive port that happens to be there. I don't really care what kind of detection it is. So I go there and I interact with it. But if we look over here at our other system, we see connection received from, I get an IP address. Attack detected, blocking access to production, blocking production 1, blocking production 2, blocking production 3, blocking production 4, and blocking production 5. So the attacker is blocked from the production environment. So now if I go back over to here and I do this same scan, I'm not going to do, let me go up to this one right here. So I'm going to do this exact same scan that I did before. And when I run it again, what we're going to see is, in this case, this is just a different service that I have running on that decoy. But notice port 22 is no longer open on that decoy, and none of the production systems are accessible. And that's really cool, right? I have stopped the attacker. But now if I'm a skilled attacker, or maybe I'm just kind of, not that skilled, but I'm determined, I say, wait a minute, I connected up to port 22 on .114, and oh, by the way, now the environment's gone. I can learn from that and come back and try something completely different. Okay, so now let's take a look at a different approach to doing this. Give me a second. Oh, wrong terminal window. Okay, so what we're going to do now is we're going to fire up a different simulation, okay? So it starts off the same. We're starting the production environment, and I'm just going to let that do its thing. And I'm literally just going to run the exact same scan that I did a second ago. And we're going to end up seeing, and by the way, this is the exact same production environment that was fired up before. There's really no difference whatsoever. You can see the same stuff's open, all that kind of stuff, okay? So nothing has changed. If I wanted to, I can go and browse to something like 225, and I still get access to that same production environment. So nothing has changed. We're back at the same starting point that we were before. So now what I'm going to do is the exact same thing that I did before. I'm going to connect up to port 2222. So when I do that, let's go over and see what happened over here. So we see, again, connection received. I get the IP address of the attacker. I block access to production. But now what I'm doing is I'm enabling some additional decoys. So let's see what happens if the attacker goes back and tries to rerun the same scan. So before, when we detected it, the attacker reran the same scan, everything was dead. When I reran the same scan again, whoops, hold on, did the wrong, I think I might have, okay, yeah, we're good there. So I just did the short scan, not the longer one that I wanted to do. Okay, there we go. So we'll go ahead and run this guy again. And when I go run this, so we've detected the attack. When I go run it, as long as I didn't break anything, it does pop up with those same ports open. Now, let's take a look at what happens. I'm just going to refresh my browser here. In this case, it is now an Nginx. It's not an Apache. Now, if I was doing real deception, I wouldn't want there to be a difference. But what I wanted to show you is what we've actually done is we've redirected the attacker to decoy systems. And from the attacker's perspective, they can still connect up to those different systems. I just need to reload. The attacker doesn't know anything bad has happened. So with this combination of zero trust being able to modify access via macro and micro segmentation, once we get a high fidelity, low noise detect, we can radically change what the environment looks like to the attacker. And from that perspective, the attacker doesn't even know that there's a problem. Now, I intentionally made differences between the production and the deceptive resources, but the fact of the matter is I only did that to make this demo more interesting. And that's the power of what we can do when we have non-production resources, environment variability, and high fidelity, low noise detection. Now, obviously, this demo didn't specifically cover the attack information. That would have to be done differently. But that's the kind of concept that I'm talking about, is being able to have these non-production systems. This is all about the attacker's perception. If the attacker continues to think that they're winning throughout the entire duration of the time, then they have no reason to change their behavior. They have no ability to learn from their mistakes because they don't even know they made them. And that's the true power when we start talking about cyber deception and deception technology. So that was kind of my quick demo there. Again, I see that we have at least one question. I will throw this one out there. So has Zero Trust plus deception tech been employed in any operational technology environments? I'll be honest, I don't have an example off the top of my head. Imran, you might. But I do know that Zero Trust and deception have been deployed, and I can tell you that I have designed deception technology to deal with operational, whether it's operational technology, industrial control systems, Internet of Things. So you can do that. I see absolutely no reason why you wouldn't also be able to do Zero Trust. The big issue with Zero Trust in OT environments ends up being there's a lot of device to device or system to system where authentication becomes a little bit more challenging. But Imran, if you wanted to jump on that as well.
No, absolutely. So I think that is deception is considered as one of the higher level maturity from a zero trust perspective around visibility and analytics. So we have certainly seen organizations adopt a deception from a zero trust maturity assessment perspective. So to get to the next level of zero trust maturity, we have seen adoption of this capability. If you look at the recent CISA roadmap that came out, it talks a lot about adopting deception type technology to help accelerate threat detection. But this was a very informative presentation, Kevin. I did have a couple of questions for you. I guess the first one is, what are some of the barriers to adoption of deception technologies have you seen as you have, worked on this industry for a while?
Sure. So I'll be honest. The barriers that I run into, one of them, let me change this guy. The biggest barrier is kind of a lack of understanding. There's this sort of perception that when we talk about deception, we're just talking about honeypots that we've been doing since 1996. Just like Zero Trust is a strategy, deception is a strategy as well. It can be implemented through different technologies, but it is a different way of thinking about how to deal with security. For example, if we think about honeypots, I can do deception with no honeypots, right? Deception is all focused on influencing the behavior of the attacker in ways that are advantageous to us. And so what I see a lot of people doing, that one of the biggest barriers is people are like, oh, it's just honeypots. That's so 1996. And then when you talk to them about it, they basically get the idea that deception is more of an alternative to an IDS, right? It's just another way of detecting attacks. And that's part of the reason why I put together this aspect or this kind of model where we talk about high fidelity, low noise detection. We talk about non-production resources, environment variability, and incident information. Yes, deception can function to provide high fidelity, low noise detection like an IDS, but IDSs and EDRs and XDRs and all that, none of them provide the non-production resources. None of them provide the environment variability. And in many cases, it's difficult even to get valuable attack information out of those. So I think a lot of the biggest barriers end up being one of knowledge and awareness. People have preconceptions.
Got it. And I just got a minute left here. One last question for you. You mentioned earlier the dwell time of being 28 days. Have there been any analysis done that shows how deception technologies have helped reduce that dwell time?
Absolutely. As a matter of fact, there have been. I'd have to look at the actual sources, but I've seen some reports that that when analyzed, deception can result in a 96% reduction in dwell time. And I've actually done some kind of modeling of my own, where I kind of played around in with just some statistics and all that kind of stuff. And what I've seen is that from an overall breach impact perspective, just using some of the modeling stuff that I've been playing around with, you can end up seeing, again, in excess of a 90-something% reduction in impact or harm as a result of employing deception technology.
Awesome. And where can one go to learn more about Calvio deception technologies?
So yeah, I mean, so obviously, Calvio's website would be a great place to go ahead and take a look at that. They've got a ton of content there. I actually also have a YouTube channel called Take Back the Advantage. It's not specific to a Calvio, but it's got a lot of information about general deception stuff as well. So that would definitely be something to take a look at. So yeah, but yeah, the Calvio's website would probably be the easiest way to go ahead.
Great, excellent. Well, thank you, Kevin, for your time as well. And back to you, Paige.
Oh, and I do see there was another question. Are there white papers or documentation you recommend for implementing zero trust in cloud environments? That would be on you, Imran.
Yeah, absolutely. You know, at Booz Allen, we're building reference architectures on how do you build zero trust implementation in a hybrid cloud or a multi-cloud environment. And if you go to boozallen.com/zero-trust, contact us. You can get in touch with us, and we can share some of those reference architectures and implementation approaches.
Cool. And I know that we're kind of at the end of our scheduled time here, so now would be the time if anybody has any other questions. Now would definitely be the time to throw those out there. You know, and you know, like I said, you feel free to, you know, I'm on LinkedIn and Facebook and all that kind of fun stuff. So if you have questions, you want to have a different, you know, kind of a different longer term conversation about deception in general, don't hesitate to hit me up. You know, whatever you need to do.
Great, thanks everyone.
Okay, well, if there are no other questions, I'd like to thank our participants as well as Imran and Kevin for being with us today. We hope the information you received during this webinar has been helpful to you and your organization. As a reminder, everyone will receive a recording of the presentation and a follow-up email. If you have any questions or would like to request more information, feel free to contact the Calvio team at Carahsoft. Our contact information is displayed on your screen, so please don't hesitate to call or email us. If you'd like to provide feedback on today's webinar, a few survey questions will be on your screen momentarily, so please stay on. Thank you and have a great day.